Hello everyone, welcome to Code Enzyme, and in this video we will discuss this problem, blocking elements. Now before starting this video, I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel and it doesn't cost you anything, but it will help me a lot. Now let's first read the problem statement. You are given an array of numbers a1, a2 till an, and your task is to block some elements of the array in order to minimize the cost. Suppose you block the elements b1 b2 till bn, and then the cost of the array is calculated as a maximum of sum of the blocked elements and the maximum sum of the subsegments into which the array is divided. So you can read this, and the constraints are t goes till 30,000 and n is till 10 to the power 5. So we want to solve this in n log n time, and actually since t is a bit less than 10 to the power 4, so we can, it is a bit lenient, we can even go a bit further than n log n, but we can't go till n square. So I think since this is a very classical problem of something like this, so we have to solve this using binary search. I mean, just by reading the question, it looked like a binary search problem, and we have to check, like for checking the mid value if it is correct or not, we have to use dynamic programming in this question. Now let's first discuss the sample input. So we have six elements. Then we have 1 4 5 3 3 2. So 1 4 5 3 3 and 2, right? Okay, now let's ask how can we make the cost equal to 7. So I think it is pretty clear, like okay, we can cut 4 and 3, not this 3 actually. Okay, we have to cut this 3, so I have to take the sum of these two, which is 7, maximum of 1 5, and 3 plus 2 is 6, and the maximum of all these is equals to 7. So yes, we can make 7, and you can try for something less than this, that is 6, and you will not be able to make anything less than this. So the answer for this one is 7. Okay, now let's also see some other test cases, like we have 1 2 3 4 5. I mean, I think it is pretty simple, you can even try it on your own, but basically just from reading this question, it is a very standard problem, and if you have solved the CSS problem set, like I have done this problem set, and it contains many of the educational problems, and there is this problem which is very similar to this. It is called array division, and we have to divide the array into case of arrays such that the maximum sum is minimum, like that. And it is this question is pretty similar to this problem, so using that I get the intuition that this problem is based on binary search. Okay, now so we are going to use binary search. So we have to use binary search, but how do I check if my mid value is correct or not? And for this step we are going to use dynamic programming. Okay, so this is basically a binary search plus dynamic programming problem. And okay, so whenever we approach a dynamic programming problem, we need to first define what our subproblem is, and is this a 2D DP or is this a 1D DP. And from the constraints, it is actually telling us that we have to solve this using 1D dynamic programming, so I won't go much further into that. So let's first define what our DP of I will represent. So I mean, one thing is sure, that okay, if I want to check for some x value, if this is, if I can make this x or not. So I want to check, like if I can make this x valid or not. Now how should I say this, like if my array is something that like this 1 4 5 3 3 2, so I have 1 4 5 3 3 and 2, and I want to check if I can make 7. So one thing I can do is okay, let's try adding elements from here. So I will take, okay, 1 plus 4 is 5. Now if I add this 5 in my answer, let's try to do this greedily without dynamic programming. So if I add 5 in my answer, I will never be able, this subsegment might go beyond 5, right? And beyond 7, right? So what I will do is I will block this 5. Then I will try to make one more. So this is, I blocked this 5. So this is my one subsegment, and then I will try to create some other subsegment. So okay, this was 6, and then I can't add this 2 to my current subsegment, so I'll block this 2 also. So my answer is simply maximum of 5, 4, sorry. My answer is simply maximum of 5, the sum of these two elements, that is 7, 6 and 5, which is equals to 7. So this is one possible way. So you might think that you can do this greedily, but I actually tried it and it gave me a wrong answer. So this was a DP problem, and you will not be able to solve this greedily. Now for which test case it will fail? Let's say we have 3 elements, something like 4, 6 and 8, and okay, let's search for, like, can we make 10? Sorry, let's see if I can make 8 using this. So I can't, so I have this subsegment 4. Now I can't say add 6 to this. So what I can do is I can simply block this element, right? And then I will go here. Now I have this 6 and I can't add 8 to this 6, otherwise this will happen, this will be more than 8. So I will block this also, and now I can make this like that. But if I do that, my 2 elements will be blocked and it will be 10. So this will give me a wrong answer if I do it greedily. So something like that will happen if you do it greedily, and it will fail for some test case. Okay, now let's try to discuss the DP solution. So what I will do is, I don't have the intuition for how you solve dynamic programming problems. The hardest part is generally to define what our subproblems mean. I mean, dynamic programming is basically, you solve a variety of subproblems which will lead to your final answer, right? So let's say dp of I, it will represent something, and that something is, I mean, generally in DP problems, what we do is we try solving for all the prefixes, and using that we are able to solve the answer for the whole array, something like that generally for such kind of problems. You can actually even do this for suffixes and it will also work, but I like to do it using prefixes, so let's say it like that. So I will say, okay, dp of I is equals to minimum sum of blocked elements okay, so minimum sum of blocked elements such that no subsegment, so all the segments that were created, I mean, I should say sum of subsegment is greater than mid. Okay, so the sum of subsegment must not be greater than mid, and what should I say, this thing that I have calculated is only for a of 0 to I. Okay, so this is what I have calculated. This is what I have named what my subproblem are. So kindly understand what the subproblem means carefully, and then we can proceed further. So now we have this dp of I. Now for this dp of I, it is very clear that my answer will be in dp of n. That means I have processed my whole array, right? Now what? Now since what are my transition states? So transition states is simply dp of I is equals to, so what will be my transition states? Okay, now let's assume, okay, let's say, let's change my subproblem a bit. I'm assuming and a of I is the last blocked element. So I change my subproblem a bit to make this more simpler. So I am assuming that the last element that I blocked was a of I. Okay, I mean the element that I'm currently at. Okay, so since that is the element that I'm currently at, my dp of I will be equals to minimum of dp of j, okay, such that j is less than I. Okay, so dp of j is the prefix of the prefix dp of I. So if I'm calculating dp of 5, then I have to consider dp of 0, 1, 2, 3, 4. Okay, and from this I have to select the minimum of dp of j such that dp of j such that j is less than I, and the sum from j plus 1 till I uh, is less than mid. So I know it is a bit complex, but this is also a deep problem. So kindly be patient with it and try to understand every step that I have written. Okay. Now this thing, querying the minimum, is actually an O of n square problem. So you can do it in O of n square easily. And if you do it in O of n square using two loops, it will be in big O of n square log n time. And I don't know, it might pass, it might fail, I don't know, I have not tried this. But since this is an O of n square approach, it will almost surely it will give you a TLE. Okay, so how do we optimize it? And obviously, since we are trying to minimize it, there are some approaches, like you can use a sets. If you are using C++, you can store these values in sets, so set int, okay, and try to query this. Or maybe you can even use maps, maybe, I don't know. What else you can use? Like obviously the very standard approach would be to use a segment tree, and maybe the most optimal approach. And what I did, like so what I did was I used a DQ. Okay, so we will not be coding anything tougher. So this is a much easier to code and almost the same complexity. But obviously segment tree is more optimal, but this is also a very what should I say, very optimal answer. So you can be a bit smart and use DQ to avoid what should I say, in the second loop I'm trying to avoid as many indexes uh, such that j is less than I, and this is actually a pretty much implementation only. So you can use any of these three approaches to query this, it doesn't matter. But the thing is that you want to be smart and reduce your time from big O of n square to something big O of n, right? And there are various implementations of this, and it doesn't matter what implementation you are using. Okay, so let's just move on to the code. And I will not be able to explain it on paper, so I will just show you how you can code this DQ approach. Okay, so basically we are just trying to do this, and we want to avoid as many I for and reduce the second loop. So this might go into big O of 2n or something like that, but it won't go till big O of n square at least. So I will create a new file, let's say, and first we have is okay, first we have an integer, then let's take an array. Okay, actually let's make it n plus 1, because I have defined my dp as the ai is the last element that I am blocking. So if I add one more element to a, then the last element will become an unnecessary element, so it will be, and it is a 0, so it will work out. Okay, and okay, since I want to query that the sum this value, the sum from j plus 1 to I is less than mid, we can actually query this using prefix sums. We can optimize this using prefix sums, right? So to use prefix sums, I will just calculate it. So let's say vector int prefix, and let's go for n plus 2, and for I prefix of I plus 1 is equals to prefix of I plus a of I, right? So initially all the elements are 0, and let's go till n because we have n plus 1 elements, and I think this should work. Okay, let's also create a DP array of n plus 3 elements, and now we are going to binary search on answer. So it is pretty easy. Let's say my high value is the sum of the array, so let's say high plus equals to a of I. Okay, and my low is equals to 1, and my answer is equals to high, while low less than equals to high. If check, I will also I will have to create a check function which will check if my mid value is correct or not. So let's say int mid is equals to low plus high minus low by 2. Okay, now I need to make a check function. If this check is correct, then I will reduce my high I will say high is equals to mid, else I will say low is equals to mid plus 1. Or maybe since I am using an answer variable, so I can say high equals to mid minus 1 and answer is equals to mid. I mean both will work, doesn't matter. Yeah, so we have this, and now I want to create a check function to check if this mid is the correct mid or not. I mean, can I make this mid? If I can make this, then I have to say okay, high, I will reduce my high value, otherwise I will reduce my low increase my low value. Okay, now to make a check function, I mean I can make a global function, but let's make a lambda function. So to make a lambda function of bool, so it is returning a bool and there is only one parameter, that is the mid value. Check of int mid, and it is returning a boolean value. Okay, so we have this. Now I think I made some mistakes. This is a lambda function, so I forgot to mention that. Yeah, okay, so we are here, and now we want to implement this function. Let's first say dp of 0 is equals to 0, and now obviously I was going to use a dq approach, so let's make a dq and I will call it q, and for I in range 0 till n. Okay, since in the end I want to delete the a of nth element from this array. Okay, now since what we are going to do is we are going to pop from this dq, let's say while, I mean this is a pretty standard approach, so I don't need to explain much, but I mean you can even use a segment tree for this, you can use a dq, or you can even use a set, but I find it much simpler, so you can just follow along for right now, and in the end you can try to understand this whole code on your own. Okay, so while q dot size is greater than 0, while my queue is not empty, and dp of what should I say, dp of q dot back is greater than equals to dp of I, then I'm going to say q dot pop pop back, then q dot push back I, and then since I made a prefix sum for this one, so I can query my summation from something to two segments in big of one time. I can say prefix of I minus prefix of q dot front is greater than mid. If this is greater than mid, then I'm going to say q dot pop front, and after this what I have to do, I can say dp of I plus 1 is equals to dp of q dot front plus a of I. Okay, once this is done, I can simply return dp of n plus 1 less than equals to mid. So I'm deleting the nth element and I'm covering all the elements, and I think this should work. In the end I have to also print my answer variable, and now let's run this and see if it is working. Okay, so it passed the test cases locally, and now let's try to submit this. I will pin this comment in the description in the comment section below, so you can copy it from there. Now let's try to submit this. Okay, so it got accepted and the runtime was only 62 millisecond. So it was quite fast, it was not slow. So I hope you were able to understand this, and if you did, kindly like this video and subscribe to my channel. I will see you guys next time. Thank you.